Hello friends, in this video I will repair this power supply with a strange problem. So it's working, it's heating and it's giving a heating smell. So let's open it up. Now I've opened up the PCB of this power supply and I can tell that this coil is burned. You can see. This should be orange like this and not black like this. So I presume the problem is somewhere around this coil. There is a short circuit. But the strange problem is that the power supply gives all the voltages are good. Now let's turn it on. And you can see all the voltages are good. Now let's see what caused the heating. As you can see, this coil, it's heating very fast. Yes, this coil is very hot. Now let's see why this coil is heating. I don't know in this power supply, but in other power supplies that I've repaired, there is a 12 volts, 5 volts and 3.3 rail on a coil like this. Now let's check this. So that's one of the windings of the coil, and I presume this one it's other. Now let's check between them. And between them there is no short circuit. Now let's check between ground. I didn't find the schematic of this power supply, but now I will tell you what I've seen analyzing this PCB. So this is the output of the SMPS transformer, these two set of wires. And this is the 12 volts, yellow, it's 12 volts power rail. So my surprise, it's the 12 volts power rail, it's connected from this coil to the transformer. And this is the ground. It's connected to a rectifying diode. Usually I've seen ground connected to the transformer and a rectifier to the plus. So here we have the plus 12 volts output, and on this small PCB we have 5 volts and 3.3 rail. And I don't know if the problem is before or after this point. And in order to see this, I will put my lab bench power supply here. I will apply 12 volts here to see what is the current consumption. For the beginning, I put 1 amp and I have only 100 milliamps power consumption. Now let's measure the 3.3. It's working, and 5 volts, it's working. So it means that the problem is not after this point, it's before this point. And the problem can be on this board who rectifies, or on the primary part. I think this board is a MOSFET rectifier. I can't see all the board, but I think there are 5 MOSFETs. It's difficult to take this PCB out, and I have to find a solution to be sure that the problem is here. So I have to analyze this rectifier board. Now let's use the camera to see if we can find something hot on this PCB. So the coil is hot. It's very hot, but I can't see something hot on that PCB. So I have to analyze this small PCB. Now let's see to the oscilloscope the voltage on that trouble coil. Now I will start the power supply. There is 36 volts peak to peak. And now the voltage on the secondary coil of the SMPS transformer. Now let's put again on the coil. So that's the original coil and original plate. And that's the replacement coil and the replacement plate. So I have to put a good plate here, and I have to take out these red wires because they are for 5 volts and they have not enough turns like yellow one. And this smaller wire, that's minus 12 volts, that I will use. Now I managed to replace this coil, and I have to say it seems easy, but that's a lot of work to do. This one has 3 wires and this one has 4 wires, but that's thick. New one is thicker than old one, and the surface is increased in a new one. Now let's put this back and make a test. So here I put poxypol, exactly like old one. Now let's test again. Voltages are good, minus 12 volts, it's perfect. I have to move this coil. Now let's measure the temperature. So that's 40 degrees. It's warm, but it's not hot. Now it's 50 degrees. The coil is 30 degrees. It's perfect and it's stable. Now let's add a load. Now let's measure again with the load. That's still 30 degrees. So I've put everything back, and now let's make the final test. Now let's put a load. Now let's try to measure the temperature of the coil. Let's see if we can. Coil is 30 degrees. And the MOSFETs are 40 degrees. So if you have a power supply like this, you should check the coil if it's heating, and if it's heating you have to replace original coil with a bigger one because it's undersized. And if you do this quickly, you will not damage the power supply, because if you wait, then the MOSFETs will be blown away, and will be more difficult to repair this power supply. Now I will put this in my PC and I will make some tests. And please notice, then even if it's rated 700 watts, I don't think this can keep this power. And my advice is to use it only on 500 or 600 watts maximum, because otherwise will not have a long life. So I put the power supply in my PC for test and I will keep it. Now let's start for the first time. So it seems everything is perfect. During test, I've noticed that this power supply has a second design error, and I will make a sequel of this video soon. If you have any questions, please put it in a comment. Thanks for watching. Bye.